Hello, my name is Mario. Welcome to another Go video. In today's episode, I'll share with you 5 new tips for writing idiomatic code. This is part number 3. Tip number 1, prefer table-driven tests. As usual, the links to the examples will be in the description of this video, so feel free to check it out. I have an implementation right here that defines a function called add and adds two numbers, and in case both of them are the same, it will return 0. Depending on your experience with other programming languages or with Go specifically, what you usually do when implementing tests will be just following the cases that you have to implement depending on the logic that you built before. So like I said, we have one when both are the same and one when they are different. So we literally have two test cases. In Go, what happens is that we have to make it more idiomatic, we need to define it in a way that is the table driven, and I want to show you what that means. So you define an anonymous struct called tests. You define a name, you define an input, which in this case will be the two values. Let's call input A an int, input B the other int, and the output, which is another int. From there you define your test cases. Now we're going to be literally copying this for now, and we're going to be doing the name will be when both are the same, the input A will be 1, the input B will be 1, and the output will be 0. And with that we have our first test case. I miss a comma here. Similarly with the one below, we take it and then we move it above, and we do the same. We do the name, we do the input A, input B, and number 3. And with that we have the two test cases that we literally have below. Another thing that we need to do to make it more idiomatic, obviously parallel, to make it run it in parallel with other when you're running the other tests. From there you implement your typical for loop, but in this case we're going to range through the tests. We're going to do a test equal test. This is because we're going to be using subtests, and when you're launching a subtest, it's actually launching a goroutine, and if you're referring to a variable that is outside of the goroutine, it's always going to be referred to the same value. And I will be leaving a link to the description to that in the description of this video to that specific gotcha, so you are aware of that as well. So trun test.name func t testing t, and then let me scroll up a little bit so you can see, and then we just literally do what we had before. So we run again, this is a subtest, so we run it in parallel. We put a got will be the value of add test input A. Oh, what the heck, that was weird. Test input B, and then we have the result. And then if got is different test output value, so we do a got want, and they print out the value which we got tt expected, right? Test expected. Now the idea of defining table driven design tests is to clearly specify the inputs and the outputs, and always define the logic that you need to do for testing that specific piece of code. You don't have to, so next time if we decide to modify this logic and add something else that changes the internal logic depending on the input, we can add those values directly in our test case and define it right there. There is no need to add more lines for that specifically. Alright, let's go into tip number 2. Tip number 2, avoid assert tests. This example is going to be reusing what we did before a little bit. So I have a sum.go file that implements an add value, but in this case, instead of receiving int, it's receiving an struct, which is value, which happens to be receiving two values. It's defining two values inside, and again similarly, if the values are the same, you return an empty value of that type. Now the way it's implemented right here is using assert, using the testify package, which is, I have nothing against using the testify package and assert specifically, but in this case this is not idiomatic. And again, this is coming from if you have experience with other programming languages and other unit testing frameworks, for example NUnit for .NET or JUnit for Java. You typically come and what you want to do is do what you did before, what you learned previously, and apply it to the new programming language. Now this works for sure, but there are different ways to do it. And why is this not idiomatic? It's not idiomatic because now we are introducing namings that you can do without adding an extra package. Now, what will you do instead? You do got different than output. You do a t fatal or error depending on how you want to do it. You do a got wanted. So got and tt output, and that's it. I mean, you don't have to import the package for something that is already in the language. With that being said, there are cases when you need to compare structures that include things that cannot be compared, like pointers or maps or interface types and those kind of things. And there's a package called GoCMP that I covered previously in another episode. I will leave the link in the description as well. That is the recommended way to compare structs in those cases. Now, if you want to compare direct things, you just use the operators that are available in the language. Again, this is something that maybe you can argue with me and we can have a conversation, but in most of the times you don't really need to implement an assert type, and instead just test directly what you're supposed to be testing instead of adding a new mini language coming from a package. Let's jump into tip number 3. Tip number 3, prefer not using the empty interface 99.9% of the time. So what do I mean by not using the empty interface 99% of the time? Obviously, when we are implementing APIs, the best way to implement those APIs, depending on what we're trying to do, is know in advance the types that we're going to be using, that we are going to be receiving and using, and then apply whatever logic you have to do to those types. There are specific cases where we don't know in advance the values that we're going to be receiving. The most common example would be a JSON payload. I mean, sure, you know how to unmarshal that into a type, but you don't know exactly because it's coming from outside of your boundaries in your API. Which is typically in HTTP handlers and HTTP endpoints and those kind of things. Now, what I'm trying to do here is, let's say we have a func do that is going to be receiving, in this case, we're trying to be clever, and we're trying to do, no, if this is a string, we're going to be printing out the message, let's say. Okay, if this is a string, then we're going to pass it in. We're going to be printing out a message that says, hey, this is a string. Otherwise, we're going to be ignoring the type. And now, in order to do that, we have to use a type assertion. So you have x, v, and then type, which I previously covered in another video as well. So I will be leaving the link in the description as well. So when this is a string, we're going to be printing out this is a string. Otherwise, we're just going to be ignoring the values. So we do x. So if we do a for val range person, we do a val, it will be running, or rather printing out only one message that says Mario, because it's that's the only type that happens to be a string. Now, if that's what you want to do, you want to have support for multiple types in your logic, in the algorithm that you're implemented in that function, perhaps you need to define an interface type that applies to the specific behavior that is defined in the type that you're receiving. With generics, you can do something similar to what you perhaps were trying to do in the beginning when trying to use the empty interface, and I will be covering generics as soon as 1.18 is released, so don't worry about that. Now, why this is not a good idea? Because you literally don't have types anymore, and everything is sort of like you don't know exactly what type you're going to be receiving, and therefore you're going to be doing this type assertion kind of things all the time. Is it a good idea to do it? I guess it depends on what you're trying to do, but 99.9% of the times you don't need that, and you can directly specify the type instead. So I can change that. If this is the only type that I'm trying to expect, well, I can say I move this up a little bit actually, and leave it outside of the outside of the range, and change the API in this method, because I'm only applying this to the do x. If I'm only doing this for the string type, it doesn't make sense to do it outside of what undefined v. Oops. Sorry, it should be here file. So in this case, it's doing something similar, but if you notice the API, I changed it to be a concrete type instead of the empty interface. This is useful again in cases where, like I mentioned before, maybe it's a JSON object that is coming from outside and you need to unmarshal it and do something about it. Let's jump into tip number 4. Tip number 4, don't return interfaces. For this example, I have a file that is supposed to be consuming two producers, and the two producers literally have the same signature, a produce method that returns a string, nothing out of ordinary. What is different between the two implementations is how those return the values, and I want to show you what I mean by that. The producer one in this package is returning a interface type called names, if you see right here. Instead of returning the actual concrete type. In this case, it's an unexported type called str that implements the produce method and returns a string, like I said before. In the case of the producer number 2, it's a cars struct that happens to be implementing the same interface, or rather the same method with the same signature, but it's not returning an interface type, but rather the concrete struct. Now, why is the recommended way to do this, the producer 2, instead of the one in producer 1? The reason being is that if you return an interface, now all your clients are going to be tied to that concrete interface type, not a specific behavior that you may have in the type that you're defining. Or to say it in a different way, if we decide to only care about cars, let's say a string, which will be a silly implementation, but let's say return string, and this one now return string. If I only care as the consumer of these two packages about the behavior of a string, I will be defining a type right here called stringer, which will be an interface because I'm the user of that interface. So my behavior, the behavior that I'm expecting from the things that I'm using, are going to be defined by the consumer of that behavior, not the other way around. It's a way to keep things separated and not force your users to use concrete details that are not really needed in the first place. This is a little bit confusing, and I'm coming from a different language. If you're coming from Java or C#, that is typically the way that you need to define the interface first, and then you need to implement that interface or extend that interface into another concrete type. And that thing is more like explicit implementation of the interfaces. In Go, things are more implicit. So the way it works is that you don't have to do any of that in the first place. Tip number 5, avoid stuttering. So what do I mean by avoiding stuttering? So I have an example here that is importing a package called file that defines file types. Obviously, they are just for demonstration purposes. So this package file defines a file type, a new file function, a fancy file type, and a new fancy file function. The idea of avoiding stuttering is to avoid the prefix, or rather the postfix that you use for your package name in your types, including functions, actual struct type, interfaces, and cases like that. So, for example, if I have a file, new file, which is the constructor of the file type, and similarly a new fancy file, and new file, fancy file. This is a stuttering because the value that we have here called file is equal to the package name. So we can get rid of that, and that will make things a little bit more idiomatic. Obviously, we need to go back and modify this as well. So we remove file from the type, name, and similar from the function. One thing that you notice is that in the case of the file, or in case of types that happen to be the same, have the same name as the package name, you still keep them the way they are. There is no need to change that. So this defining a file package with a file type is still idiomatic because that's what it is. That's the name of the package, rather the type. So it's not a big deal. What will not be idiomatic, like I said before, is having a new file function. In this case, that's kind of redundant and you don't need it. So that's it. Those are the 5 tips for writing idiomatic code in Go. Thank you for watching, and we'll talk to you next time. Take care. Stay safe.